Section 7.2, molar mass. Molar mass is the mass of a substance per 1 mole of that substance. We find the molar mass by using the periodic table. This is going to be your best friend in Chapter 7. The molar mass is found by adding together the atomic masses of all the elements in a given substance. And we use units of grams per mole because it's the mass per 1 mole. Molar mass is used a lot in chemistry because it's used as a conversion factor to convert from grams to moles and moles to grams. Simple example of a molar mass. For one element, it's the same as its atomic mass. You just use the units of grams per mole. I use silver for an example, symbol Ag. If you look on the periodic table, silver has an atomic mass of 107.9. Sorry. Okay, where was it at? Silver, I had my finger on it. Okay, right there. 107.9. So the molar mass would be 107.9 grams of silver per 1 mole. Now here I wrote it as a conversion factor because we're going to be using molar mass as a conversion factor in section 7.3. Okay? Or you may see the molar mass just written simply like this, 107.9 grams per 1 mole. Okay? Just like when you have a speed limit of 65 mph, miles per hour. That speed limit is saying that at maximum you should go 65 miles in 1 hour. So the 1 is implied by the slash or the abbreviation. Okay, so it's something over, it's a unit conversion. Okay, that's what molar mass is too, a unit conversion over 1 mole. Okay, or if we're going to go and use it as a conversion to go the other way, we'll see we'll have 1 mole on top and the grams on the bottom. That's section 7.3. Okay, I don't want to jump ahead with that yet. I want to do a few more examples of finding a molar mass of a compound. It's not just made up of 1 element. Let's do a couple examples of finding molar mass of some compounds. Okay, let's find some molar masses of the following compounds. Sulfur trioxide. We have 1 sulfur, we have 3 oxygens. Look up on the periodic table the atomic mass of sulfur and the atomic mass of oxygen. Sulfur has an atomic mass of 32.07. And I'm using the periodic table that is from your textbook. If you're looking at a different periodic table, okay, you might see slightly different masses. The periodic table in your textbook and the blue one that I have here, which is also from the textbook, just an earlier edition, has all of the significant figures for the atomic masses rounded to 4 significant figures. Okay, so I'm using that one. Oxygen is at 16. Okay. One times 32.07 is 32.07. 3 times 16 is 48. We need to add those 2 numbers together. You get 80.07. The molar mass would be 80.07 grams per mole. I'm going to show you it as a conversion factor as well, because that's how we're going to use it in the next section. So I want to get some exposure to it is as a conversion factor. Okay. So this is written as conversion factors. Okay. So it's very simple. You look right at the periodic table. Okay, the periodic table is a chemist's best friend. Always have this chart handy, okay? For pretty much most of the stuff we do throughout the rest of the course, okay? Find the molar mass of the next compound. Okay, we have now, this is an ionic compound. This is iron 3 sulfate, if we had to name it, iron 3. Remember the 3 came from the charge of this ion. I'll just put that up here. Iron 3 sulfate. Okay, let's find the molar mass. We have 2 irons. Now, be careful when you're counting the sulfur and the oxygen. This 3 that's in the parentheses, outside the parentheses, applies to everything inside the parentheses. So we have 3 sulfurs and 12 oxygens. Okay, we have 3 sulfate units, but individually we have 3 sulfurs and 12 oxygens. This 3 as a subscript only applies to what's in the parentheses. This 3 does not apply to the iron. Okay, as the subscript, it only applies to what is in the parentheses directly before it. All right, so now we need to look up the molar masses, the atomic masses of each individual element. Iron has an atomic mass of 55.85. Yeah. Sulfur, we just wrote on the previous example. Oxygen is 16. Okay, these numbers come from the periodic table. Okay. All right, so now we need to multiply those out. 111.7, 96.21, and 192. Okay, then you'd add them together. $399.91. That would be the molar mass of iron 3 sulfate. I'm going to write it as a conversion factor as well, because that's what we're going to do in the upcoming section. Use it as a conversion factor. And that's how we find the molar mass. Okay, we are going to use molar mass as a conversion factor. We will use molar mass to convert quantities that are in grams into moles and quantities that are in moles to grams. Unlike Avogadro's number, which is used for any substance, molar mass is unique to each individual substance. It's not the same whether if it changes for each substance. So you need to have the molar mass calculated on the side, okay, or calculated initially before you use it as a conversion factor, because it's unique to each substance, unlike Avogadro's number in the first section, which stayed the same for any substance. So now what we're going to do is we're going to use molar mass as a conversion factor. When we use it as a conversion factor to solve problems, we'll have it in these types of this format here. Okay, in this kind of format. All right. So let's use molar mass in calculations. Okay, so we learned how to find a molar mass. Now we need to use molar mass as a conversion factor, which is what it is most commonly used for. Calculations of molar mass. Okay, as I've said, molar mass is used as a conversion factor to convert grams to moles and moles to grams. Let's do a couple examples. I have these 2 ready, and then I'd like to do probably about 2 more. Okay, so let's start with something simple, a simple element. Convert 0.350 grams of silver to moles of silver. Okay, we need the molar mass of silver. Molar mass of silver 107.9 grams per 1 mole. Okay? All right, now this was from a previous problem, this molar mass. Right, trying to start off simple here. So we want to convert grams of silver to moles of silver. Well, we need to flip this. We need 1 mole on the top because that's our desired unit. And the given unit is the moles. I'm sorry, the given unit is grams, sorry. Okay. So convert grams into moles. So now we have 0.350 divided by 107.9. And that would give us the amount in moles, 0.00324 moles of silver. You could put that in scientific notation as 3.24 times 10 to the negative third moles as well. I don't like to squish things on the board here, but it's leaving me no room to do otherwise. Okay, so either or is fine, scientific notation or the expanded form. Okay, but if you had like 8 zeros in front of the first non-zero number, it would be advisable to put it in scientific notation just to keep it neat, right, and not have all these zeros running. But that's how we would do the conversion, okay? The molar mass is used to convert from grams to moles, and now we're going to do one where we go from moles to grams. So we want to convert the moles of sulfur trioxide into grams of sulfur trioxide. Now we just calculated the molar mass of sulfur trioxide in the previous section. We calculated that at 80.07 grams per mole. Okay, we have that on the previous board. Okay, so we've done that step in another problem. But if you didn't, you'd have to calculate it, okay? Which we are going to do one like that. Now let's convert moles of sulfur trioxide into grams. And 1 mole of sulfur trioxide, remember molar mass is always 1 mole. The mass varies depending upon what the substance is, but it's always per 1 mole. That's the definition of molar mass. So you're always going to have with mole the number 1. Whether it's on the top or the bottom depends upon what you're solving for. Okay, so the given units cancel out. And you get a mass with 3 significant figures to match the initial measurement of 127 grams of sulfur trioxide. Okay, so this was the answer for number 1. This is the answer for number 2. My board is getting a little bit written on too much, so let me try to clean it up a little bit so you can copy it down and view it. Okay. And we can do another example. Actually, I'd like to do 2 more examples. This is a very critical part of chemistry, molar mass, and using it in conversions. So I don't believe that it's a waste of time to do 4 examples. Okay, Okay, let's do another example. How many moles are in 308 grams of barium sulfate? Barium sulfate is used in gastrointestinal studies to see if there's a blockage in the intestines. Sometimes it's called the barium drink, or some other common name. But this is the substance that's used. It's insoluble in the gastric fluids, so it allows for imaging to be done and see where a blockage is at. Okay, let's do a conversion, converting the grams of barium sulfate into moles. we need the molar mass. So first, find the molar mass. That's our conversion factor. We have 1 barium, 1 sulfur, and 4 oxygens. To look on the periodic table, barium is atomic mass of 137.3, sulfur is 32.07, and oxygen's at 16. 1 times 137.3 is the same thing for sulfur. 4 times 16 for the oxygen is 64 total. And we add them up together and we get an overall sum. Okay. 233.37 grams per mole. So now we will use that molar mass to do the conversion from grams into moles. So 308 grams barium sulfate. We want to convert into moles. 1 mole in the numerator on the top, and the 308 grams barium sulfate in the denominator on the bottom. Denominator D down below. That's how you can always remember those terms for a fraction, which, you know, this is a fraction. Grams cancel out. Oh, sorry. All right, 233. All right. Okay. We get 1.3, 2 moles of barium sulfate. And that's how you would find the amount of moles in a mass sample of this substance. I want to do one more problem with molar mass as a conversion factor. Let's do one where we find the grams if we're given the moles. Okay, we'll do one more problem with molar mass conversions. Okay, let's do one more problem using molar mass as a conversion factor. How many grams are in 0.750 moles of aluminum sulfate? Now, aluminum sulfate is used in manufacture of some deodorants and antiperspirants. It may not be the ingredient in your deodorant of choice or antiperspirant of choice, but it is used in some of them. Each manufacturer uses their own aluminum-based complex. This is one of the more simple ones, but ones like Secret and Speed Stick or whatever, you know, one. They have slightly different ones. But anyway, this is something that is used in manufacture of deodorants. Okay, let's find the molar mass before we can do this conversion. We need the molar mass as our conversion factor. Find the molar mass. 2 aluminum, 3 sulfur. Remember that 3 applies to what is exactly inside the parentheses. And 12 oxygens. Okay, so we go to the periodic table, the chemist's best friend, and aluminum has a molar mass of 26.98. Sulfur is 32.07, and oxygen is 16. Okay. Now, I've been looking at the periodic table for a very, very long time. So sometimes I know the masses off the top of my head, but I do realize this is the first time taking chemistry for most people. So you may need a little bit more time to look at the periodic table to find the element and find the mass. That's fine, okay? So now we do the calculation. 2 times 26.98, 53.96. 96.21 and 192. Now we add these together to get the molar mass. (342.17 grams per mole. And that's what we will use as a conversion factor to go from moles into grams, which is our second part. We want to convert it into grams, so 342.17 grams of aluminum sulfate, aluminum sulfate. 342.17 grams of aluminum sulfate per 1 mole of aluminum sulfate. Sulfide and sulfate are different, yes. Units of moles cancel out. Your overall answer with 3 significant figures like the initial measurement, 257 grams of aluminum sulfate. And with those significant figures, okay, this calculation is a calculation involving multiplication and division. Remember the rules for significant figures in Chapter 2 in calculations. When you're doing multiplication or division, your final answer has the lowest number of significant figures. So in this case, our measurements, I've conveniently put up with 3 significant figures. Initially 3 significant figures. The math is multiplication or division, depending upon which way you're solving. The rule is the same. Report the final answer with lowest number of significant figures. Being that it is a multi-step problem with finding the molar mass as the conversion factor, don't worry about significant figures in the molar mass. Okay, don't worry about rounding off. Just keep them as is, so that you don't have an error that's propagated. If you round too early, your final answer is going to not be as accurate as it should be because you've rounded off too early. So don't round off here, do the final round off there. Okay? All right, so sections 7.1, 7.2, 7.3 are very important. Please make sure that you're practicing the problems that I've recommended in the book. Even though that you don't have to send them in, you use them as self-check. If you have trouble doing it, you need to reach out to me so I can help you. You do not want the test to be the first time that you're trying to work through the problems, okay? I'm here to help you and answer any questions that you have regarding this, okay? You can email me and we can do it by email, we can talk on the phone, we can do Zoom, whatever works out. But please, if you have any trouble when you're working through the problems on your own, okay, reach out to me. If you have any questions with any of the videos and anything in there and you've rewatched it and it's still not making sense, just reach out to me, it's no problem. Okay, we're going to now go on in the next segment, in the next video, we're going to talk about mass percent calculations.